Kuzangbo and welcome to Bhutan e-learning project. I am Sonam Sring, a teacher from Lobesa Lower Secondary School. Today I will be presenting a science lesson for Key Stage 3, that is classes 7 and 8. This video lesson will take you through the topic homogeneous and heterogeneous mixture. Now, before we go into the lesson, let us go through the objectives of this lesson. Firstly, by the end of this lesson, you all should be able to explain homogeneous mixture and heterogeneous mixture with examples. Secondly, you should be able to identify separating techniques for the mixture. So, these are the two objectives which you should be able to fulfill at the end of this lesson. Before we learn about homogeneous and heterogeneous mixture, let us recapitulate what you have learned in lower classes. Matter. I am sure you all have learned about matter in your lower classes. So, what is a matter? Matter is anything that has mass and occupies space. Any substance around yourself except for lights, shadows, heat, rest all fall under matters. Matter comes in three states, that is solid, liquid and gas. Now, matter can be further divided into two types, that is pure substance and mixture. Pure substance, you already know, it's a substance or a material which is made of a single type of substance. Further, pure substance can be divided into two types, that is elements and compounds. Now, we are not going to look upon pure substance, elements or compounds because these topics will be covered in other video lesson. So, today our focus will be on mixture. So, what is a mixture? I am sure by looking at the name itself, you all can derive the meaning of the word. So, mixture, when we put two things together, that forms a mixture. Let us go by the textbook definition of the mixture. So, mixture is a substance which contains two or more substances combined physically in any proportion. So, if you find any two substances put together, that will form a mixture. Let me try to explain this mixture with the help of an example. Now, if you look in this picture, you can see there are sand and gravels. Now, this is a mixture. Why? Because we have sand and gravel. There are two substances present in it. So, that forms a mixture. Now, let us take another example. In this picture, you can see water and oil. So, when these two substances are combined together, we form a liquid mixture. There are plenty of examples of other mixture around yourself. You can explore that on your own after understanding what is a mixture. Now, mixture can further come in two types, that is homogeneous mixture and heterogeneous mixture. So, our main focus of the lesson will be to understand what a homogeneous mixture is, what a heterogeneous mixture is. Now, in order to learn about this homogeneous and heterogeneous mixture, I am going to do a short demonstration. So, in other words, I am going to prepare a mixture. So, for that, we are going to need some materials. So, the material required to prepare this mixture are water, then we have copper sulfate. These blue crystal are the copper sulfate. Then we need sulfur powder, this yellow powder that you see here is the sulfur powder. We need beaker, we need spatula, and we need a glass rod. So, using these many materials, we are going to prepare a mixture. Now, let us go by the instruction. Let us see how we can go and prepare the mixture. Firstly, fill the beakers with the water. So, here I have already poured 100 ml of water in 2 beakers, and we have labeled them A and B. Next, now after filling the beakers with water, add 2 spatula of copper sulphate in beaker A. Here it goes, 1, 2. And in the next beaker, that is beaker B, you add 2 spatula of sulfur powder. Now, using a glass rod, we are going to stir the mixture. So, in order to get a fair result, make sure that you give equal amount of stir to both the mixture. Similarly, let us stir beaker B, which has got water and sulfur powder. Now, we are going to keep this mixture undisturbed for 5 minutes. After 5 minutes, this is how your mixture is going to appear. Do you notice any difference in these 2 mixtures? Yes, there is a difference. Now, let us first look at beaker A. Now, this is the mixture with water and copper sulphate. What do you observe? So, here in this beaker, we can see that the copper sulphate has completely dissolved in the water, meaning the particles, the components of copper sulphate and the components of water are evenly distributed. Hence, our eyes cannot distinguish the 2 substances present in this beaker. So, such type of mixture where the 2 substances completely mix with each other are called as homogeneous mixture. Now, let us go by the book's definition of what is homogeneous mixture. So, like I said, the mixture where the components are uniformly distributed throughout and cannot be distinguished is a homogeneous mixture. Please pay attention at the words which are underlined and italicized, because these words are the key words to understand what is homogeneous mixture. In the homogeneous mixture, the particle arrangement will be somewhat like this. In this picture, you can see the purple particles and the green particles are evenly distributed. That is the reason why our eyes are unable to distinguish the 2 separate substances in the mixture. Let me give you an example. For example, we add eggs and flour to make a bread. So, when this egg and flours are mixed together, we get a bread. And when you look at the bread, we cannot distinguish which one is egg and which one is flour, because the particles of these 2 substances are evenly distributed. Similarly, there are thousands of examples of homogeneous mixture. Homogeneous mixture can also be in the form of solution, especially when there is liquid involved. We form solution if the substance is soluble. For instance, when sugar is added to water, we form a sugar solution. So, sugar solution is also one of the type of homogeneous mixture, because in sugar solution also we cannot distinguish the two different components. Metal can also form homogeneous mixture. For example, the brass bell that you see hanging in your school is a homogeneous mixture where you have copper and zinc added together. Also, the bronze medal that you win in different types of sports is also example of homogeneous mixture, because in bronze we have copper, zinc and tin mixed together, but our eyes cannot distinguish, mainly because the particles are distributed uniformly. So, this is what a homogeneous mixture is. I hope you have understood about the homogeneous mixture. Now, let us look at the other beaker. Now, in this beaker, you can see that the sulfur powder is floating on the water. Some of the sulfur powders are at the bottom. So, here, did the sulfur powder mix with the water? No, here the sulfur powder has not mixed. The components of sulfur powder is floating on the water, and our eyes can clearly distinguish the two substances, meaning in this case the particles are not distributed evenly. That's the reason why our eyes can clearly distinguish between the two substances, that is the powder and the water. So, such mixture where the components does not mix, or where the particles are not distributed uniformly, such mixture we call it as heterogeneous mixture. So, what is heterogeneous mixture? Let us look at the definition. Heterogeneous mixture is a mixture where the components are not uniformly distributed and are easily distinguishable. Again, please pay attention at the words underlined and italicized. So, in other words, heterogeneous mixture is just the opposite of homogeneous mixture. The particles are not, the components are not uniformly distributed, and our eyes can easily distinguish the different substance present in the mixture. So, in a heterogeneous mixture, the particle arrangement will be somewhat like this in the picture. As you can see, the purple particles are all on one side, whereas the green particles are all on the other side, which shows the unequal distribution of the particles. So, our eyes can easily separate the two substances present in the mixture. Now, let us look at an example. Here we can see red clay soil. When we mix this red clay soil with the straw, we get a Bhutanese local bricks. Now, this local bricks are examples of heterogeneous mixture, because we can easily separate the different components present in it. Similarly, you can find lots of other heterogeneous mixture in your surroundings. I want you all to go on and list down as many heterogeneous mixture that you can find in your house. So, now we have learned about homogeneous mixture and heterogeneous mixture. I hope you have understood its meaning, its definition, the examples, the particle arrangement. Now, let us see how much you have understood. So, for that, I want you all to distinguish between homogeneous and heterogeneous mixture with an example each. Can you all do that? I am sure you all can do that. Now, let us look at one more question and check our understanding. Imagine you are given a cup of milk and a spoon of sugar. Now, what type of mixture will be formed by using those two substances? You will have to justify your answer. Do you think you can get the answer correct? I am sure you can. Okay, now let us get back to our mixture that we have prepared earlier. Now, the first mixture where we have water and copper sulfate. This is a homogeneous mixture. Now, what do I do if I want the copper sulfate back? How do I separate the water and the copper sulfate? Can you help me out? Okay, the technique that I am going to use to separate this mixture is very simple, which you perform every day at your homes. That is, I am simply going to boil this mixture. What will happen when I boil this mixture? When the water reaches 100 degrees Celsius, the water will start to evaporate. When all the water particles evaporate, what remains behind is the copper sulfate. So, that is how I can separate this mixture. Did you all get it? So, the separation technique that I used to separate this mixture is boiling, or the process involved in this technique is evaporation. On the other hand, again I have a mixture here. If I want to separate this mixture, what do you think I need to do? Here, since we can easily distinguish the two substances, the best method that I can use to separate this mixture is by filtration. So, when we filter, all the liquid particles will go down the filter, all the liquid particles will go down the porous medium, and the solid particles will be left behind as a residue. Here, the separating technique that I have used is filtration. So, the next thing that we are going to learn is separating techniques. What techniques can we use in order to separate different types of mixture? In the first case, for water and copper sulfate, the homogeneous mixture was separated by boiling and evaporation, by boiling or evaporation. In second case, sulfur was separated from water by filtration. So, the separating techniques that I have used is boiling and filtration. Let us look at some of the other methods which we can use to separate the mixture. So, now we are going to look at some of the separating techniques that can be used to separate the different types of mixture. The first technique that we are going to look upon is filtration, which I have already explained in earlier case. Now, what is filtration? I am sure this is not a new word for you all. Filtration. Filtration is a separating technique where the components of the mixture containing insoluble solids in a liquid bypassing the mixture through a porous medium. So, especially this filtration can be used to separate insoluble solids from the liquid. Example, if you have a muddy water and if you want to make that water clean, you can separate the dirt and the water by filtering, by using a filter paper or by running through a thin transparent cloth. You can even use this filtration in order to separate the dust from the air. Now, this is how a filtration is done in the lab. So, you have a funnel with a filter paper inserted. When you pour the mixture of muddy water into the funnel, the water having the smaller particles will fall down through the filter paper and leaving the larger, the bigger particles of dust on the filter paper as the residue. I am sure this is not a new technique, so you all must be knowing it very well. So, I am not going to focus much on filtration. The second method that you can use for separation of mixture is distillation. What is distillation? Distillation is also a process to purify liquids and separating the mixture of liquids into individual components. So, when you use this distillation method, you can not only separate the components of different substance, but also you can separate the components present in individual substances. For example, this is how the distillation apparatus is, where you have a distillation flask and you put the mixture into the flask. When you add on the heat, the liquid will start to evaporate. When it reaches the condenser, the hot vapors will slowly change back into the liquid and it will fall down as a pure water. So, this is how the distillation works. I am sure you all must have carried out this experiment in your lower classes. So, what are some of the mixtures that you can separate with this method? Example, if you want salt and water, you can use this distillation. If you want to separate sugar from the water, you can use this method. Similarly, there are other mixtures which you can use to separate the mixture. Now, distillation has 3 types. The first one is simple distillation. Simple distillation is very similar to that of distillation. In this case, this method will separate the component of mixture in which the boiling points are different. So, distillation mainly works whenever there is a liquid present in the mixture. So, the apparatus is also similar to that of distillation. Now, where do we use this simple distillation? These are used in production of beverages. It is also used to prepare distilled water for labs, and also there are many other mixtures, homogeneous mixture as well as heterogeneous mixture, which can be separated by simple distillation. The second type of distillation is steam distillation. Now, this might be new to some of you. Steam distillation is also similar to the other distillation that you have learned. So, basically in steam distillation, what happens is steam distillation will purify the mixture which have the components that can decompose at higher temperature. So, if we have organic components like plants, they get decomposed when we apply high temperature. So, using the steam from the liquid, we can separate the components present in the mixture. For example, so this is how the steam distillation looks like. Now, let us look into a short video which will help you understand steam distillation much better.
Take a look at this distilling apparatus. The bottom reservoir is filled with distilled water. Above is an alembic chamber that holds the plant material, often called biomass. The biomass is full of tiny sacs that contain essential oil. When the water boils, the steam passes up into the chamber. As the steam passes through the biomass, the temperature causes the tiny sacs to burst open, releasing the essential oil. The essential oil rises up with the steam, and together the oil and steam pass into a tube. This tube passes through a cold condensing chamber. The cold temperature changes the steam back into liquid, which drips out of the tube. The liquid collects in a new reservoir where the water and oil separate naturally. The water, which is called hydrosol, is left at the bottom, while the oil rises to the top. And lastly, the essential oil can now be collected and bottled.
I hope with this video you have understood how the steam distillation works. Now, where do we use this steam distillation? We use this steam distillation in production of perfume and essential oil for our bodies. Let us move on to the third type of distillation, which is fractional distillation. Fractional distillation, it's a method to separate the component of mixture in which boiling points are different. So, here in order to separate the mixtures, the boiling point of the substances should be different. And the special thing about this method is you have an extra and special equipment added to the distillation apparatus, which we call it as the fractionating column. In this picture, you can see fractional distillation being used to produce different kinds of fuel from a crude oil. Now, again let us have a look at a short video in which a fractional distillation is used to separate a homogeneous mixture, that is acetone and benzene. You know, acetone and benzene, they are homogeneous mixture. Our eyes cannot distinguish between the two substances. So, acetone and benzene forms a homogeneous mixture. The boiling points of these two liquids are different. Hence, we use this fractional distillation to separate the two liquids. Let us have a look at a short video.
Let's take an example. Separation of acetone and benzene by fractional distillation. As the difference in boiling points of acetone, whose boiling point is 329 Kelvin, and benzene, whose boiling point is 353 Kelvin, is only 24 Kelvin. Their mixture can be separated by the process of fractional distillation, using fractionating column. Let's see how this can be done. The mixture is taken in the distillation flask. Fractionating column is inserted between distillation flask and Liebig water condenser. The flask is heated on water bath. At a steady temperature of 329 Kelvin, acetone distills out, and is collected as first fraction, in the receiver. The vapors of benzene are cooled in the column, and liquid benzene trickles down back into the flask. When acetone is distilled out completely, the temperature starts rising, and the receiver is changed. When the temperature becomes steady at 353 Kelvin, benzene distills out, and is collected as second fraction, in the receiver. Acetone and benzene can be further purified by redistillation, using simple distillation apparatus.
So, this is how fractional distillation works. For your information, both the videos were downloaded from the YouTube. Now, the third and the last separating technique is chromatography. Chromatography can separate a mixture of color or more soluble solids from a mixture. This chromatography is especially used where there is color involved in a mixture. There are three types of chromatography, that is paper chromatography, gas chromatography and column chromatography. So, where can we use this chromatography? We use this chromatography in identification of components in a mixture. Also, this chromatography is very helpful in investigating crime scenes. This chromatography can also trace qualities of contaminants present in the groundwaters. It is also used for the quality control of the foods. And lastly, chromatography can detect the drug components in urine or in other bodily fluids. These are some of the applications of chromatography. Now, let us explore paper chromatography. In order to do that, I am going to instruct you how to carry out the paper chromatography, and after that you are going to write down the observations. Is the instruction clear? Firstly, take a strip of napkin paper or filter paper with 10 cm as its length and 4 cm as its breadth. Now, from the bottom, draw a line about 2 cm. After you have drawn the line, you take a drop of ink and place it on the pencil mark. make sure the drop of ink does not go below the line. It should be in the center. Add a drop of ink on the pencil mark. Now stick the strip of paper to the pencil using a sellotape. In this manner. Put some water in a glass or a container. Place this paper strip in the container in such a way that just the bottom of the paper touches the water. Leave your setup aside for 10 to 15 minutes. After 10 to 15 minutes, take out the napkin paper and dry it. Observe what changes do you see on the napkin paper. That is your task. That is how the paper chromatography works. Now, since we have learned the different types of separating technique, it's time for you to check your understanding. So, here you can see a list of separating techniques and followed by the different types of mixture. Take some time to go through this table and then think which separation technique can be used to separate different types of mixture. Okay, now let's check it together. So, if you have got this correct, I am sure you have understood the separation techniques. Lastly, it's time to think again through the topics that we have learned. So, I have two questions here which you are going to answer. If you are able to answer this correct, that means you have understood the lesson. The first question, during monsoon, we face the problem of muddy water in our taps. So, what possible techniques can you use to make that water clean, and also why would you use that technique? You have to explain. Secondly, the lab assistant accidentally poured water in the spirit. So, how would you help him or her to get back the spirit? You have to explain in detail. So, that is all for today's lesson. Thank you so much for watching.